Okay. So as we were explaining, when you have such a group of persons, okay, you would have to dash out. You don't have any choice than to give out the rooms according to their status, because you cannot go and say that, oh, assemblyman came first, then you give him the best. You would have issues, okay? All right. So the same way, these operators, arithmetic operators, right? They have different status, if I may put it, okay? So whenever you find them in an expression like this, you have to apply those rules. Now, let's look at it. There are some of these operators that are called multiplicative operators, okay? They are multiplicative in nature. Multiplicative, okay? Why do we say they are multiplicative? Technically, if you are doing division, it's another form of doing multiplication, right? For instance, instead of maybe 2 divided by 3, I could write 2 times 1 divided by 3. Is that okay? So division, your multiplication itself, division and modulo, these are all multiplicative operators, okay? And anytime you have multiplicative operators, they have the highest precedence. So highest what? Precedence in terms of the arithmetic operators, okay? In terms of the arithmetic operators. Then we have the additive operators. Additive operators. So the additive operators, we have addition and subtraction. These guys are the next in terms of the arithmetic operators. They are the next. So that means that if you have an expression, you have to first look, evaluate or solve multiplicative operators before you attempt additive operators. Is that okay? So in this particular expression that we have, let me show you how the computer solved it. So first of all, let's put this one down first and then evaluate a typical example. So with this in mind, assuming I give you 3 minus 5, okay, plus maybe 3 minus 5 plus 9, okay, times 2. How are you going to solve this? Remember, first look through, find the multiplicative operators, right? Fortunately, we have multiplication here. So what will happen is you will skip subtraction, skip addition, and first evaluate this multiplication. So we have 9 times 2, which gives us what? 18. So our next step is going to be 3 minus 5 plus 18. Is that okay? 3 minus 5 plus 18. Then, now we have addition and subtraction, right? Which all have the same. So this means that multiplication, division, and modulo, they have the same order of precedence. Okay. So now take it as 2 assemblymen came together, right? Or maybe to make things short, let me just take this away. All right. So now we have 5 plus 18. And we can solve this to be equal to what? 23. Is that okay? Great.
Yep.
But if we look at, now let's look at another analogy. You are in charge of the event, but you're expecting 5 assemblymen. You have the same type of rooms. One is better than the other in that order, right? How are you going to dash out the rooms?
First come, first serve.
First come, first serve. You dare not reserve the best for one assemblyman when another came first, okay? So in that case, they all have the same status, okay? So you do what? First come, first serve. Now, in programming, we say that you apply the left to right rule, okay? So for instance, now let's try to evaluate this thing. Let's try to evaluate this problem, right? In here, we have division, modulo, and what? Multiplication. And these guys are all having the same status. Take it that they are all ministers. Is that okay? you have to dash them the rooms, and the rooms don't have the same status, if I may say, right? The only thing you can do is to do first come, first serve. So in this case, since division is coming first, you have to evaluate division first before the next. Is that okay? But you have to make sure you evaluate all the multiplicative operators before you come to the additive operators, okay? So that means our next step is going to be 4 divided by 2, which will be 2 plus then 5 mod 8, mod 3 minus 8 times what? 2, right? So now we've evaluated the division. Which is the next one? The modulo. So our next step is going to be 2 plus, now what will 5 modulo 3 give us? What will 5 modulo 3 give us?
2.
2, right? So that gives us 2 minus 8 times what? 2. Okay, now we are left with only one multiplicative operator. We have to evaluate it. So our next step is going to be 2 plus 2 minus what? 8 times 2, which gives us what? 16. So you see, now we are done with all the multiplicative operators. We are left with what? Additive operators. And fortunately, these two guys still have the same order of what? Precedence, isn't it? So that means we have to evaluate the addition first. Now, 2 plus 2 gives us what? 4 minus what? 16, isn't it? Then now we have only the subtraction. So we have 4 minus 16, which gives us what? Minus 12. So that is how the computer evaluates it. Please, is this okay for everyone? Hello, are you guys with me?
Yeah.
Okay, so let me now give you another one to try. Try this for me. Please, this time get the answer right, okay? 8 times 4 minus 5 divided modulo 6 modulo 4 divided by 2. Solve it and tell me what the answer will be. Please don't use the computer, don't use the calculator. In fact, you can't punch modulo on your calculator, so you can go ahead and use your calculator, but don't use your computer, okay? All right, so solve it and give me the answer. Who is Ghana India Kofi Annan Center of Excellence in ICT? Who is joining us? Ghana India Kofi Annan Center of Excellence. Has anybody shared the link with someone else? Okay, please, what is the answer? Any answers? Any answers? Now, you see, what we are doing right now, we are trying to lay down a foundation, right? And you have to make sure you get these things right, because if you don't get your foundation right, you would be shaky. Yeah, so any answer for this? Oh, okay, Freddy, okay. Who has finished computing this? Please don't use the interpreter. Any answers?
31.5.
31.5. Okay. Any other answer? Any other? So we have 31.5. Any other? Any other? Ebenezer, Fedi, and Hills. Any other answers? Please don't use the editor, the interpreter.
31.
Okay, so I'm getting 31. Any other?
I'm struggling to have the same split screen as you're having. Mine is up and down, and I want it side by side.
So just right click the down one. You know there is this bar on the down one. If you right click it, then you select move to left. Yeah. Yes. Any other answers?
I have 31.
31. So okay, we have two people having 31. Okay, Fedi says his mic is misbehaving. All right, so let's see. Let's punch it directly. 8 times 4 minus 5 modulo 6 modulo 4 divided by 2, right? So 31.5. Okay, now let's look at y. So first we evaluate what? Multiplication, right? So this gives us 32, right? So our next step is going to be 32 minus 5 mod 6 mod 4 divided by 2, okay? Then what will be our next step? So we have a modulo here. So 5 mod 6 will give us 5, sorry. So we get 32 minus what? 5 mod 4. Mod 4 divided by 2. We still have mod here. So 5 mod 4 will give us 1, right? So that gives us 32 minus 5 mod 4 will give us 1, then divided by what? 2. So technically, we have 32 minus half, which is 31.5. Is that okay? All right. Now, Python has one more arithmetic operator. You see? Yeah.
My problem has to do with the 5 mod 6.
Okay, so 5 mod 6, right? Anytime, modulo simply means that if you divide this by that, what will be the remainder? Okay, now so ask yourself, can I completely divide 5 by 6?
No.
So if I try to divide 5 by 6, would there be a remainder?
No. It can't even divide.
Exactly. So 6 would divide 5 0 times, remainder 5.
Oh, okay.
You get a point. So the simple trick is that whenever the first operand or the left-hand side operand is smaller than the right-hand side operand, it will return the left-hand side operand. That's all.
Okay.
Great. Okay. All right. So now let's see. We see when I do 3 divided by 2, Python gives me 1.5 because for Python, the division sign in Python is actually true division, okay? Python's division is true division, just like we have in mathematics, right? Now, in languages like C++, if you do division like we've done here, instead of 1.5, you get 1. Now, that's a situation called integer division, okay? So if you want to do integer division in Python, then you have to use double division sign, okay? So if you use the double division sign, then we call it integer division. Now, what integer division does is it will only give you the whole number part of the division. So for instance, if I do 3 integer division 2, instead of 1.5, I get 1. If I do 5 integer division 2, I'll get what? 2. But if I do 5 divided by 2, I get 2.5. Please, do you get what is happening here? So in Python, we have true division and we have what? Integer division. The true division is the default. The true division is the default. So if you want to do integer division, which comes in handy, there are times in code that you want to do integer division, okay? It comes in handy, you use that. Okay.
And I'm getting an error. I don't know where the error is coming from.
What did you do?
3//2.
Is it forward slash or backward slash? What's the error saying?
Oh, the error is at line 1, chart 3, /3//2. You must provide a value expression following the.
So please check it. Check whatever you've typed well. Okay, just check it and make sure you are in the Python interpreter, not the command prompt.
Oh. I'm not in the Python interpreter.
Okay. All right. So now you see, so far we've talked about this arithmetic operators, but you know there are times where we can actually insert parentheses, right? There are other things called like parentheses, okay? So aside the arithmetic, logical, relational, there are other types of operators. So we have the parentheses, which we may call brackets in maths. We have exponents. So let me write them in full. Parentheses, that's this. We have exponents, okay? Now, in Python, if you want to do exponents, you do double star, right? So if I want to do something like 2 raised to the power 3, that is 8, or so yeah, 2 cubed, you have to do 2. Okay, so that's the exponent. Double asterisk is exponent. Is that okay? So if we put all of them together, parentheses has the highest, okay, in the order of precedence. In fact, if I'm really listing the order of precedence, putting everything in the order of precedence, putting everything in there, then number 1 would be parentheses. Let me hash it. So number 1 would be parentheses, followed by exponents. Oh, come on, what's happening? Followed by exponents. Then the arithmetic, guys. Let me write in full arithmetic. Then we have the relational. We will be looking at relational operators. Then we will have, lastly, the logical operators. Okay, so this is the full order of precedence. Now, with the same work that we did here, where is our good? This particular work, we know that. So we were given this, and we know that we always have to evaluate the multiplicative operators first, right? But you see, if I come here and wrap 3 minus 8 in parentheses, then I change the ball game altogether. Okay, so take it as this. So you have a minister, you have an MP, you have an MCE coming for an event, right? And that same event, you have an assemblyman and you have a school headmaster. You see, technically, if you look at their status, the school headmaster will have the lowest, right? And I stand to be corrected and not to disrespect anyone. But the school headmaster will likely, politically, at least politically, right? The school headmaster will have the lowest status politically. True or false? Good. But assuming the school headmaster was actually sent by the president to speak on his behalf, That means the school headmaster is coming in the stead of what? The president. So take this bracket as what? The presidential status upping. So because he was sent by the president, he has to be given the appropriate what? Appropriate treatment, because whatever treatment you give to the school headmaster is just like you are doing it for the president. Please, do you get what is happening? So although he is just a school headmaster, because of the presidential tickets he holds, he has to be given priority. Is that okay? So by wrapping this in parentheses, we are forced to evaluate this first, and that would definitely change the answer for this. So let's look at it. So our first thing, the first thing we will have to do would be 4 divided by 2 plus 5 mod. We have to evaluate the bracket or the parentheses first. So that's going to be what? Minus 3 minus what?
Next 5.
Minus 5, okay? So that will give us minus 5. That will give us minus 5. Now we have a very big challenge here. In fact, I have no idea what will happen when you move a positive number by a negative number. So let's find out from the interpreter. So let me do something like 5 mod minus 5. I haven't actually tried this before. So, okay. So the negative sign doesn't have any effect, okay? The negative sign doesn't have any effect. Or let's really be, let's be sure. Okay, so we got negative 3. That's interesting. Okay, so what if it is the negative 2 that rather has that? Yep, positive 3. Now, this is interesting. Okay, so modulo means divide and give me the remainder, right? So if I divide 2 by minus 5, in fact, I would have to spend time on this mathematics. I have no idea what is happening. So I'll research it and tell you tomorrow what is happening here. So for the sake of this, let me rather change this guy to maybe 12 so that we have a positive number to deal with. So now 12 minus 8, that gives us what? A 4, right? You get a 4 times what? 2. Then business continues as usual. Please, do you understand?
Yes.
Exactly. So anytime you have parentheses on anything, then you have to evaluate whatever is in the parentheses before any other. So parentheses has the highest order of precedence in any mathematical operations, okay? And also if there is an exponent, you make sure you evaluate the exponent as the next thing before the arithmetic and relational operators. Please, are we crystal on this? Fantastic. Good. So that is for arithmetic operators. Now, the next in the set is relational operators. Okay. So let's look at relational operators. Relational operators. In mathematics, we call it inequalities. We call them inequalities. In mathematics, we call them inequalities, right? And which of them do you remember? Which inequalities do you remember?
Less than.
Less than. Unfortunately, we have less than.
Greater than.
Greater than.
They are greater than. What else?
Less than or equals.
So now, to represent less than or equal to, we use less than and equal to together without space, right? But I've installed some fonts on my PC and that's what I'm using. So if I do it, it will convert it to a normal less than or equal to symbol or equal to symbol, right? But take note that doing this is what? Just less than and equal to put together without space between them. Please, do you understand?
Yes.
So if on yours, you won't see this, okay? In your editor, you won't see this. All right, then what else do we have?
Greater than or equal to.
Greater than or equal to. What else do we have? We also have not equal to. Okay.
Yes.
Now we use the exclamation sign for not plus the equal to sign, making not equal to. But as usual, my fonts will change it to this, not equal to. And finally, we have equal to, which is also double equal sign. Is that okay? So these are the arithmetic operators that we have. Is that okay? Arithmetic operators. Now, in these arithmetic operators, anytime you use an arithmetic operator, you will get a data type, a special data. In fact, as part of the data types, I only talked about the numbers and strings, right? So let me quickly mention something here. So the data types, I said we have the numbers. We have the numbers, we have the strings, right? We also have the set of data types called Boolean. Okay. Now, Boolean represents true or false. Okay. So anytime something will result to true or false, we call it a Boolean type. Okay. So Boolean types are true or false values. Now, anytime you make comparison, for instance, if you say 2 is greater than 3, the result is either true or false, isn't it?
Yes.
So anytime you use any relational operator, your result is going to be a Boolean value. So take note of that, okay? And in Python, the Boolean values are true and false. Now take note, the true and false start with capital T. Is that okay? So let's go to our interpreter and have some fun. So if I say something like 3 is greater than 5, is that true or false?
False.
So if I hit enter, I get false, right? If I do 9 is less than 4, that's false. If I say 6 is greater than 3, I get true, right? If I say 6 is greater than or equal to 6, I get true. If I say 7 is not equal to 8, I get true. Okay, if I say 6 is equal to 5, I get false. Okay, so these are what we call the relational operators. So anytime you use them, you get what? You get a true or false statement. Is that okay? So for instance, if I want to check whether a certain number is an even number or not, right? Let's see how we can teach the computer how to find even numbers. So first of all, we need to know what even numbers are. So help me, what are even numbers?
Numbers that are divisible by 2.
So numbers divisible by what? 2, right? So now how do we teach? So what are examples of these even numbers? Examples of even numbers.
4, 8.
So 2, 4, 6, 8, that order, right? Good. Now, before we close for today, let us quickly write a program that evaluates even numbers. So I'm going to comment out this. We are going to write a program that the program will take a number from the person and it will tell the person that the number is an even number or not. Once again, I'm going to use things that you haven't learned, but you will get to learn them and know how to do it, okay? But I just want to demonstrate something to you, okay? So first of all, I want this to run until I close it. So I will do something like this. Don't worry about this. You get to understand probably tomorrow, okay? Then I'll ask the person to enter a number. So I'm going to save that number and I want it to be an integer. So I'll say, again, what I'm doing here, don't worry, you will understand it tomorrow. Then I'll call input. Input is a method, a function that we use to take text something from the user. So if you want the user to type something, you use the inputs, then you pass it a message, the user a message. So enter an integer, right? So enter an integer. Is that okay? So the user is going to enter an integer. Then this is what we want to do. Say if number, you see, if we said that an even number is a number that's divisible by 2, right? So how do you think we can write a mathematical expression to represent divisible by 2? Based on what we have learned so far, how can we write a mathematical expression to represent divisible by 2? Any ideas? Now, okay, if something is divisible by 2, that means if I divide by 2, there wouldn't be any remainder, right?
I think I can say something.
Okay, so how would that be?
So if number equals
so that is definitely not going to work.
If number equals int mode.
Oh, okay. Definitely this is not going to work. Any other any other? Yes. Whoever gets it. Come again. I didn't hear what you said. Can you repeat?
The number mode 2 equals 0.
Okay, so number mode 2 equal. Now equal this one.
0.
Equals 0. Like this?
Something like that.
Something, no, you have to be sure. This code you are writing, you have to be sure. So is it true or false?
False.
You are not sure. Okay, then let me clean it. Who else? Yes. Any other? All right. No, you see, so we know of the modulo operator to give us a remainder, right? So if we say that something is divisible by 2, it means if we divide it by 2, we don't have to get a remainder. So how do we represent we don't have to get a remainder? We can just say the remainder should be equal to what? 0. Remember, if we do number mode 2, this is going to give us a remainder. So we are saying the remainder should be equal to 0. Now take note, this is what we call equality, double equal to sign. The single one, let me put it here. The single equal to sign is called an assignment operator. And it is not equal to as we know in mathematics, okay? So, Yakubu, you weren't sure, but the only mistake you made in what you did was that you said it was supposed to be a single equal to, okay? Remember, this is not called equal to. This does not express equality. It is an assignment operation. We shall look at that tomorrow, what we mean by an assignment operation, okay? All right, so I'll do this. So I'm saying that if number mode 2 equals to 0, then it's an even number, so print. I'll print, again, I'm going to do some things that you haven't learned, and I'll say number is even, okay? It's even. Now, if it is not even, then it will be what? Odd, right? So I'll say else print, and then I'll do F, say number. Our time is almost up. Number is odd, right? Okay, so now let's go for a run. And this program will run and run and run until I kill it myself. So let's print an empty line here. Okay, so let me exit the interpreter and clear the screen. Now let's run the program by calling Python and the name of the file. So it says enter an integer. Now let me clean things up. Let me put a colon and a space here. Control C to kill it, because this thing will run indefinitely. All right, so we run this again, sorry. Run this again, enter an integer. Okay, Jacob, give me an integer. Any integer. Come again.
256.
256. So 256 is even, right? Ebenezer, give me a number, any integer.
Okay, 31.
31, and you know 31 is odd, right? Okay, Hills, any number?
79.
79 or 39. What did you say?
79.
Okay, so that is odd. Freddy, your turn.
18.
18, and we know that 18 is what? An even number. So you see, just this little instruction that we have here, we've been able to teach our computer how to find even numbers or how to separate even numbers from what? Odd numbers. Okay. All right. So this session is just 2 minutes out. Any questions up to this point? Because this is our last session for today. God willing, tomorrow we're going to look more of this. Write programs that can find all the prime numbers, factorizations, and all those stuff, okay? So don't miss tomorrow, and let's always come early as we do all the time. Any questions up to this point? But the curious ones, you can probably snapshot this and try and practice or play around it. Any questions? Any questions up to this point? We have just 1 minute.
Hello.
Yeah.
So please, mine is not actually a question. I just want to find out. Yesterday, I was looking out for the video or the class that we did yesterday.
Okay.
And WhatsApp group, but I did not find it.
Yes. So yesterday I had an internet issue, so I couldn't upload. Right. So I'll be doing the yesterday's and today's right now, the moment we are done with it. So you will get them today. Okay.
Thank you.
All right. So thank you. Is there any other question? Look, the beginning will be slow like this because I have to take my time, make sure you understand the things you are doing. Is that okay? The time to run will come. But right now I have to treat you with care because you are like X. If I don't take, I'll frustrate you. Okay. So this is just a gist of what you'll be doing. Okay. And if you are not excited already, be excited, please, because a lot of more interesting stuff are on their way. Okay. All right. So thank you. See you, God willing, tomorrow for another session. Good night.